Hi guys. Okay, so last two problems, 75, and I've also included 76, and these relate to the colligative properties of the solutions. So in this question 75, we are trying to find the freezing point of the final after you add the KCl, as a solute in 111 grams of KCl, you add to 1 kilogram of water. Okay, so then in that case, what is the final volume? What is the final freezing point of the solution? So always in this case, write down the formula. So the formula here is delta T. Now here we are talking about freezing. So F is equal to I times K F times M dash. What is M dash? M dash is the molality. So what is the molality? What does it mean? It means kilograms. It means the moles of the solute over the kilograms of the solvent. So let me write this down here. Moles of the solute, and in this case, it is the KCl over whatever kilograms are given to you, kilograms of the solvent. So this is the scenario with the molality. Okay, that's one piece. Next is KF value is already known and will be given to you, and that is negative 1.86 degrees Celsius kilograms per mole. Okay, so that's given to you. So what is the value of I? I is that Van 't Hoff factor. So it depends on the number of ions, and the number of ions in the solutions. In the case of KCl, KCl is going to give you 1 potassium ion and 1 chloride ion. So this becomes, so the value of I is equal to 2. So you just have to count the number of ions, okay? Or for the molecules, that is 1. Now, delta TF is the is a change in temperature. So this relates to the final temperature minus the initial temperature. And normally we are dealing with water. So the freezing point, this is known already, the freezing point of water is the value of T initial, and that's the initial temperature, and that is equal to 0 degrees Celsius. So this value is known. This value is known, will be given to you. And the rest of it is just you have to determine from the question. So here the question is actually asking you to find this final temperature. What is the value of this final temperature? This one, okay? So, so let's put this here. Okay, so first find delta TF is equal to, that's a freezing, is equal to I means 2 times negative 1.86 degrees Celsius kilograms per mole, okay, times the molality. Molality is, oh, sorry, I forgot one thing here, totally forgot. The molarity, so we need to convert the, let's put it here, convert, I'm sorry, that should have been done first. Okay, anyways, so convert the 111 grams of KCl to moles, okay, in order to put that in molality. So totally forgot about it. Okay, so here we have potassium. The weight of the potassium, the molar mass, is 39.41. So molar mass of KCl is equal to 39.10 plus chlorine is 35. So 39 plus 35, and that gives you 74. Okay, 74 grams per mole. Okay, so here we have 74 grams per mole. In this case, you will be using this 111 grams of KCl times 1 mole of KCl, 1 mole KCl over 74 grams of KCl. Okay, and this gives you what? So if you have 111 divide by 74, and that gives you 1.5 moles of KCl. This is the number you're going to use. Okay, moles of KCl. So here you put 1.5 moles of KCl over 1.0 kilograms of water as a solvent. Okay, so here we will see that the moles and the moles cancel out, kilograms and the kilograms cancel out, and we are just left with the unit of degree Celsius. So let's multiply this. So 1.5 times 1.86, okay, 1.86 times 2, and you get here 5.5, and that's divide by 1. So 5.58 degree Celsius. So that is the change in the freezing point. Okay, so what is the final freezing point? Interestingly here, and that is negative. This is negative. This will still be negative. So, and it makes sense also. Yep. This is equal to negative. So this is delta T. Do I have the space here? Delta TF is equal to T final minus T initial. And remember, we need to find the T final. So here, delta TF is negative 5.58 degrees Celsius, okay, is equal to T final we are finding minus the T initial, which is 0 degree Celsius. So when you do it, when you do the math, then it basically minus 5.58 degrees Celsius is the final temperature. So when you add 111 grams of KCl solution in 1 kilogram of water, then the freezing point of that solution goes down. It's lower than 0 by 5.58 degree Celsius. Okay, so that's one problem. Next is finding the boiling point. Now, here's the thing. In this case, I just added this problem because I just wanted to make sure that you understand. So here, the T initial, the boiling point of water is that T initial, and that the boiling point, it's not the, water would be, it's a glucose is being added to water, is 100 degree Celsius. So same thing. Now, the only thing is this is glucose, and this thing does not electrolyte, like it doesn't ionize. So this is a non-electrolyte. So for non-electrolytes, the ones that do not ionize, the Van 't Hoff factor or the value of I is equal to always 1. So because these are still molecules, it cannot be 0 because these are molecules. They are going to have an impact on the boiling point and the melting point, or the freezing point of the water. So here we are going to do this same story. You will write this down. Delta T. Now in this case, it's boiling. Okay, we need to find the boiling point when 2.12 moles of glucose are added to 1 kilogram of water. What would you do? So here delta TB is equal to I times KB times M dash. Delta TB is equal to I is 1. Now the value of KB, I have to write this down. KB will be given to you, and that is 0.52 degrees Celsius, kilograms per mole. Okay, so this is known, and molality we will have to write this down here. So times KB is 0.52 degrees Celsius, kilograms per mole. Okay, times molality is 2.12 moles. Okay, over 1.00 kilograms of water. Okay, so this is the moles of sugar or glucose. So let's put the sugar glucose. Okay, so we cancel out kilograms and kilograms, moles and moles cancel out, and you're just left with the unit of degrees Celsius. So let's do this here. 0.52 times 2.12. Okay, this gives you, this is n times 1. So all this is change in the boiling point is 1.10 degree Celsius. All right, so now, but the question is, what is the final temperature? So delta TB is equal to T final minus T initial. Okay, so let's put the numbers here. So here it is 1.10 degrees Celsius is equal to T final, which is what we are trying to determine, minus the T initial is 100 degrees Celsius. So when you solve it, it is 1.10 degrees Celsius plus 100 degrees Celsius. And this is T final. Okay, so this becomes, the T final then becomes 101.10 degree Celsius. That is the final temperature. So final temperature or the boiling point. Okay, the final boiling temperature of the water when 2.12 moles of sugar is added to 1 kilogram of water. Then it is going to boil at 1.10 degrees higher than its boiling point. So that is why we say elevation in boiling point, and we say depression in the freezing point. Elevation is what? The boiling point of the solution is always going to be higher than 100, always. So just make sure you check that answer. Always the boiling point is higher. Always, let me write this on here. Always boiling point of solutions is like aqueous solutions. If they are insoluble in water, aqueous solutions is higher than 100 degrees Celsius. All right, so that's one thing. Next is the depression. So always the freezing point of, oh, what happened here? Something, okay, I don't know what happened here. Okay, let me read this here. Freezing point of solutions is always lower than 0 degrees Celsius. So in case you are confused about your answer, you can get it from there. Okay, guys. So this finishes the homework problems. And thank you for watching.